All right, so we have about 8 problems to go. Turns out the last 3 don't look that bad. So I'm going to handle problem 16, first doing it on my calculator. So for 16a, I'm going to graph this on my calculator. I have to do some parentheses, but my calculator is going to give me a decimal answer. I'd like to say that I'm going to get a non-decimal answer that equals the decimal answer here in a second. So 3x squared divided by x upper cubed plus 5. E to the 5th is a huge number. I'm going to graph this and figure out what e to the 5th is. So on my calculator, I'm going to second quit and do second ln e to the 5th. E to the 5th is 148. So my x max needs to at least go to 148. I'm going to make my x max go to 150. So window x max 150. That will be good enough. If I tried to do the computation on my calculator for this, because my x max wasn't big enough to handle that, I'd get an error. Graph doesn't look so good, but I don't care. I can still get the answer. Second calc. Lower limit, second ln e squared. Upper limit, second ln e to the 5th. And I get a nasty decimal, I imagine. Took a lot of, took a lot of thinking to get 8. I'm going to round that to 0.99. I'm going to get an answer. Why the heck would I put e's in here? I have no idea why the e's are on this problem. But we both have e's, so let's just deal with them. I really don't know why. This is surprising to me. So let me not write these numbers in here just because it takes a lot of time to do. And let me rewrite this problem as something that has a negative exponent. So I took this denominator, pretended it had an exponent of 1, and brought it up to the numerator. Now this becomes a U substitution problem. Oh, my calculator's answer is probably not. I'm going to get a different answer by hand, and it's not going to equal my calculator's answer. My calculator isn't going to be as accurate as me this time, believe it or not. Let me do my U substitution. I'm going to let U be x cubed plus 5. Then du dx is going to be 3x squared. So I'm going to rewrite this, and I'm going to have, in for the 3x squared, I'm going to put a du dx. In for the x cubed plus 5, I'm going to put a u. And I still have the dx, but I'm going to cancel the dx. And so this is really the integral of u to the negative 1 du, or if I want to, 1u to the negative 1 du. And the integral when you have a number times x to the negative 1 power is that number times the natural log of x. In my case, these x's are u's, and my a is a 1, so it's going to be 1 times the natural log of u in an absolute value. Turns out that I won't really need the absolute value because both the numbers here are positive, so I don't have to worry about absolute value so much. So that's the antiderivative. Of course, I need to make the u into x cubed plus 5. So what I'm trying to do is take the natural log of x cubed. Oh, it's going to be ugly. My calculator, I might not be able to do better than my calculator. I thought I was doing things in my head, but I got ahead of myself. So I need to plug in e to the 5th, and I need to plug in e squared. No, I'm not going to be able to get an answer that isn't the decimal answer, so sorry. Well, I don't think you hardly really care. But for 16b, I expect to get the same kind of answer. So I'm going to make my 2 parentheses with a minus sign between. In the first one, I'm going to go the ln of e to the 5th cubed plus 5. And in the second one, I'm going to do the ln of e squared cubed plus 5. I'm going to do both of these on my calculator. These, you can't do anything but get a decimal because of the plus 5. So this is really the natural log of e to the 15th plus 5 minus the natural log of e to the 6th plus 5. I'm just trying to clean this up a little bit so I don't mess up on my calculator. So for this one I'm going to get a decimal, that one I'm going to get a decimal, and I'm going to live with the decimals. There's no way to make those non-decimals that I know of. So first one I'm going to do natural log of second ln e to the 15th plus 5, close that parentheses, and I get 15. I'm going to say that's 15 rounded to 2 decimals. And the second one, I'm going to do the natural log of second ln e to the 6th, close the parentheses for the exponent, plus 5, close the parentheses for the natural log, and I get 6.01. Now I'm going to subtract these and go 15 minus 6.01, and my calculator is smarter than me. I thought I was going to beat my calculator, but I was wrong. I can't make that into a fraction. Natural logs produce irrational numbers that don't have fraction equivalents unless they come out to a nice integer. So that's everything I can do for 16. I don't know why I decided to put the e's there, but you've got the same issue for problem 15. It should be just about the same problem. And I am not going to live with problem 17 and 18 the way they're written. It seems silly. So 17 and 18 had these crazy e's on them again because I thought I saw something. I know that I probably, when I wrote the problems, I did them in my head, and all of a sudden I said, oh, this is going to be cute, but it wasn't so cute. So I changed my problem 17, I changed your problem 18 to have different numbers than they would have because these will be better. So let me try to do problem, oh gosh, no, that won't work. It's undefined there. Let's go from 1 to 2 on each of ours. Sorry, sometimes when you think on the fly, you run into a trap. So I'm going to make yours go from 1 to 2, mine go from 1 to 2. Let me enter this up here, clear this junk on there, y equals, clear this, and I'm going to go 4x up arrow 3 plus 5 divided by parentheses x up arrow 4 plus 5x. Just zoom standard. I don't know what the window needs to be, but 1 and 2 will handle a standard window just fine. And now second calc number 7, lower limit 1, upper limit 2, and for 18a, rounded to 2 decimals, I'm going to get 1.47. And I think when I do 18b, that's the best. I'm not going to be able to get a fraction equivalent for that because this is a natural log problem, and natural logs, unfortunately, don't turn into fractions. So let me handle rewriting 18b, and I'm going to save the 1 and the 2 for later. So when I rewrite 18b, I'm going to bring the denominator up to the numerator and put it in a parentheses with an exponent of -1. Now I'm going to do my u substitution. I'm going to let u equal x to the 4th plus 5x, then du dx. The integral of x to the 4th is 4x cubed. The derivative of x to the 4th is 4x cubed. The derivative of 5x is 5. So now I'm going to substitute. In for this, I plug du dx. In for that, I plug u. Still have the dx. I'm going to cancel the dx. This gives me the integral of u to the -1 du. And that's your just vintage natural log. So that's the natural log. I don't really need absolute values because those numbers are positive. So it's going to be the natural log of u. I'm going to change that to the natural log of x to the 4th plus 5x. Evaluated it from 1 to 2. That's going to force me to plug 2 and 1 in for these. First I'm going to plug 2 in. So I'm going to do the natural log of 2 to the 4th plus 5 times 2 minus the natural log of 1 to the 4th plus 5 times 1. I'm afraid to enter this on my calculator so much. This is 16 plus 10. So that piece is going to be the natural log of 26. And this is 1 plus 5. That's going to be minus the natural log of 6. So I'm going to do each one of these separately. I'm going to do the natural log of 26 on my main screen. So second quit, natural log of 26, and I get to 2 decimals, 3.26. And then minus the second one, natural log of 6, I get 1.79. Now I'm going to subtract them. 3.26 minus 1.79, and it's lovely that it's 1.47. That's the best I can do. When the integrals have natural logs in them, you're stuck with decimal answers. I can't probably get out of those decimal answers. So went through it a little bit quicker because I didn't think it was that grungy. So give 17 a go. We just have a few problems left. Well, maybe more than you care to have, but we have a few left. So let me do 20. 20, it's on my calculator, it doesn't matter how it's written. So let me do 20 on my calculator. So y equals, and then 4 divided by 4x minus 12 up arrow cubed. That's fine. Graph it. Second calc. Lower limit -2, upper limit 0. This one I think I'll be able to get a fraction answer because there's going to be no natural logs in it. So my calculator, normally I'd carry 2 decimals worth of accuracy, but I'm not going to write -0.00. I just threw in a couple of 2's there. If you gave me -0.002, that would be fine. So that's part A. For part B, I need to rewrite the problem. I'm going to drop the numbers temporarily. And when I rewrite this, I'm going to write it as having a negative exponent. I'm going to do u substitution. So I'm going to let u equal 4x minus 12. Then du dx. The derivative of 4x is 4. The derivative of minus 12 is 0. So for that 4, I'm going to put a du dx. And for that, I'm going to put a u. I'm going to leave the exponent of -3, and I still have the dx, which is about to cancel. So this gives me the integral of u to the -3 du. I add 1 to the exponent. -3 plus 1 is -2, and I divide by -2. I'm going to clean this up by moving the u down to the denominator. I'll leave a 1 in the numerator. That gives me -1 over 2u squared. And that negative, because there's only a monomial in the denominator, can be bumped up to the numerator. So that's the integral, or the antiderivative, with a u. I need to change the u to 4x minus 12. So this integral is going to be -1 over 2 times 4x minus, new sheet of paper. Once you get down to the bottoms, I just start fudging up. So this integral is -1 over 2 times 4x minus 12 squared. I need to evaluate it from -2 to 0. So I need to plug 0 in, go -1 over 2 times 4 times 0 minus 12 squared minus -1 over 2 times 4 times -2 minus 12 squared. And again, I'm afraid of my calculator skills. So inside this parentheses, 4 times 0 is 0. 0 minus 12 is -12. So this is going to be -1 over 2 times -12 squared. And -12 squared is positive 144. So this is going to be -1 over 2 times 144. That's going to be -1 over 288. Calculator free, because I'm worried I can't do this on my calculator. Bring this minus sign down, work on the inside here. This is -8 minus 12, which is -20. So this is going to be -1 over 2 times -20 squared. I think -20 squared is positive 400, but I'll do that here for you. -20 squared is positive 400. So this is going to be negative 1 over 2 times 400, which is minus negative 1 over 800. That double negative goes positive. So now I have negative 1 over 288 plus 1 over 800. So lots of math there I did in my head because I was afraid to do it on my calculator. I'm trying to get a fraction that's equivalent to that. Let me see if I can. So when I do these on my calculator, I'd like to see a bunch of zeros and a 2. So I'm going to go negative 1 divided by 288 plus 1 divided by 800. And I get that lovely, exactly the same answer that my calculator gave me with the couple zeros after the decimal. Let me math enter it to get the better answer. So negative 1 over 450 would be the best answer for part B of number 20. So if you don't have LNs, and the numbers aren't ridiculously large, any decimal answer should be made into a fraction. All right, so there's 19 for you to do, and then we just have a few more problems. I'm getting fatigued, so I imagine you are, unless you took a good break. I didn't take quite long enough of a break. All right, 22a on my calculator. So for 22a, y equals clear 12x squared divided by parentheses x up 3 plus 5. Graph that. Cool graph. Second calc, number 7. Lower limit 3, upper limit 4. And I get, this I'll probably be able to get a better number. So 3.07 is what I got. No, I won't. But this is an LN problem. It's going to be a decimal. And you get LN's decimal answers where you're stuck with. And I'll show you that this is an LN in a second. Let me rewrite it to do 22b. I'm going to bring the denominator up. I'm going to put it in a parentheses. It didn't have an exponent, so there's an implied 1 for its exponent, and then I'm going to get a negative 1. As soon as I get that negative 1 exponent, I get natural logs. Natural logs, I'm going to have decimal answers. So now I'll do my u substitution. I'm going to let u equal x cubed plus 5. Then du dx equals the 3x squared. But I need 12x squared, and I have 3x squared, so I need to multiply by 4. So I'm going to get 4 du dx equals 12x squared. So now I can do my substitution. In for the 12x squared, I'm going to put a 4 du dx. In for the x cubed plus 5, I put a u. Then I still have this dx over there that I'm about to cancel out. This gives me the integral of 4 u to the negative 1 du. Negative 1 exponents to always turn in the natural log, so that's going to be 4 times the natural log of u. I don't need an absolute value because the x values are positive. And I'm going to change this to 4 times the natural log of x cubed plus 5. And the numbers I have to plug in are 3 and 4. I eventually need to bring those numbers back. I just hold off on writing them to the very end. And now I do my 2 computations. My 1 computation is 4 times the natural log of 4 cubed plus 5. And the second one is 4 times the natural log of 3 cubed plus 5. I'm going to get a decimal expansion for each one of these. And this one is 64 plus 5. So that's 4 times the natural log of 69. That's easier for me to enter. And this is minus 4 times the natural log. This is 27 plus 5, which is 32. I'm going to do this one separately and this one separately on my main screen. So second quit, clear, 4 times the natural log of 69 is 16, I'm going to say 0.94. And then minus 4 times the natural log of 32 is 13.86. Probably should have carried more decimals. If I did 16.9364 minus 13.8629, my answer would probably be closer to the 3.07 that I was trying to get. If I just did 16.94 minus 13.86, my answer is 3.08 for 22b. That kind of difference I can live with because it's a rounding difference. If I would have carried more decimals and did 16.9364 minus 13.8629, actually 13.8629, then I would have got something that rounded to 3.07. The fact that I rounded to 2 decimals, so I tell you to round to 2 decimals, that could cause your answers to part A and part B to be off, like mine turned out to be off. That I can live with. When the derivative or the integral has an ln, you're stuck with a decimal answer. There's no way to get out of that decimal answer. All right. Ugh. 24a. Y equals clear 2x second e to the x up arrow 2. There's the function. Graph it. Second calc, second calc, second calc, second calc. Thank you. Lower limit 0, upper limit 1. I get 1 point. I'm going to round that to 1.72. Let me try to do the work by hand now. So I'm going to need to do U substitution. I'm going to let u equal to x squared. Then du dx is going to be 2x. So I'm going to rewrite this without the numbers. The 2x is going to turn to du dx. The x squared is going to turn to u, and then I have the dx. Dx's cancel. This gives me the integral of e to the u du. And that's the nicest integral. E is its own integral, or antiderivative. So this is e to the u. I don't need the plus c. I'm going to change the u back to x squared. So I'm going to have e to the x squared evaluated from 0 to 1. I'm going to plug 1 in and go e to the 1 squared. And then I'm going to plug 0 in and do e to the 0 squared. E to the 1 squared is just e to the 1. E to the 0 squared is e to the 0. These don't really need to be in parentheses because they're just monomials. So this is going to be e minus 1. Much nicer answer than the decimal answer that my calculator gave me. So for e functions, I generally have e's in my answers as opposed to decimals. Let me make sure that e minus 1 is 1.72 by going second, quit, clear, second, and divide for my e, and then minus 1, exactly 1.72. So I feel good about that. Your 23 should work the same way. We just have 3 problems left. They all look easy to me, which doesn't comfort me because they probably aren't. So this is just pulling out some tricks from section 1, I think. So 26 I'm going to do on my calculator. So y equals clear, parentheses, 4x squared minus 5x minus 3 divided by x. Graph it. Again, I don't need to see the graph. Second calc 7, lower limit 2, upper limit 6. And I get for 26a something that I'll probably do better. I'll probably get a fraction version of this. So 40.70, that's rounded. To do the integral, I can't do U substitution. When the denominator was just a monomial, oh, I won't be able to do much better than that. I take that back. I thought I was going to be able to do a better answer. I'm not going to be able to because of the natural log that's going to pop up. So what I need to do for this problem, it's not U substitution because the denominator is a monomial. You have to divide each term in the numerator over the denominator. We did that earlier, but it's been a while. And now this is good. I can keep writing the 2 and the 6 because I'm not doing the U substitution. 4x squared over x, the x's cancel, you're left with a 4x. 5x over x, the x's cancels, you're left with a 5. It's really minus 5x to the 0. And the minus 3 over x, I move the x up to the numerator and get a negative 1 exponent. Now I'm going to integrate. For this one, I'm going to add 1 to its exponent. Its exponent was 1, so it turns into 2. Divide by 2. Bring down the minus and the 5. I add 1 to the exponent of the x and get 1. Divide by the new exponent, which is 1. Last piece has a natural log, so you get an x to the negative 1, so you get a natural log. This natural log makes it so my 26b is going to be a decimal as well. So now I need to make a parentheses, separate it with a minus. Oh, this is actually 2x squared. So it's 2x squared minus 5x minus 3 natural log of x. Evaluate it from 2 to 6. So I should probably simplify it before I jump into calculator mode. So the first one's going to be 2 times 6 squared minus 5 times 6 minus 3 times the natural log of 6, and then minus, and I'll shoot it down a little bit lower because I won't fit it, 2 times 2 squared minus 5 times 2 minus 3 times the natural log of 2. Those are my two parentheses. For each parentheses, I need to get them down to a single number. On the main screen of my calculator, they're decimals because of the natural logs that I can't get rid of. So first parentheses is 2 parentheses 6 squared minus 5 parentheses 6 minus 3 natural log of 6. I'm going to round this to 2 decimals and live with it. I get 36.62. Bring down my minus sign, make this into a number. So 2 parentheses 2 squared minus 5 parentheses 2 minus 3 natural log of 2. That one comes out to minus 4.08. I have a double negative there that I'm going to turn to plus. So this is 36.62 plus 4.08. I'm going to do this on my calculator now. 36.62 plus 4.08. I get 40.7 for my answer to part 26b. And the beautiful thing is, when my calculator did part 26a, I got that same 40.7. I can throw that extra 0 if I want to see that extra 0. So give 25 a go. Let's skip 27 and 28. And for the last problem, just do 29 and I'll do 30. So we'll go ahead and skip these. These aren't particularly hard. They're not any new tricks. We've done so many problems, I feel like we've done enough. I'm kind of at the end of my oomph. So for 30, part A, I'm going to do this on my calculator. This is one of these problems that's so easy it's hard. So when I do 30 part A, I'll enter on my calculator just the number 4, hit my graph button, wow, and then second calc, lower limit -2, upper limit 3, and I'll get the answer as 20. To do 30A by hand, I should probably rewrite it with an x, because that 4 doesn't have an x, that doesn't help me. I could make that 4 have an x to the 0. Now I can add 1 to the exponent and divide by the new exponent. I'm going to get 4x to the first over 1. Evaluate it from -2 to 3. 4x to the first over 1 just simplifies to 4x. So now I just need to plug in 3, put a minus sign, and plug in -2. 4 times 3 is 12. I'm not putting these in extra parentheses because they're just monomials. They don't need an extra parentheses. So I get 12 minus -8. The double negative goes plus. I get 12 plus 8, which is 20. So my answer to 30B is 20. My video's, oh heck, let me just run that down. So you have 29 to go, and 29 is just like 30. Do it on your calculator. Add that x to the 0 in so you can do the integration easier. And then that will be the end of this section. We only have 2 sections left to go for the whole semester other than a review.